Hi everyone, today we will see how to solve a combination circuit for the given requirement. For example, the requirement is given as follows. Design a combination circuit with 3 inputs and 1 output. Means they are asking us to construct one combination circuit where it is going to take 3 inputs as parameters and it is going to produce 1 output. Guys, you know the meaning of combinational circuit means which is going to produce the output based on the present input. We can simply call it as combinational circuit, right? So this combinational circuit is going to take 3 inputs. Let us assume that the inputs are A, B and C, and this combinational circuit is going to process that and it is going to produce one single output. That is what they are trying to say for us. Okay, so how to produce this output, single output? For that they have given different kind of statements. Let's see the first one. The output is 1 when the binary value of the input is less than or equal to 3. You have to make sure less than or equal to 3. Otherwise you have to make it as 0. Means if you are going to write 3 bits, 3 bits means what? It will be like, assume it as 001. When 001, what is the respective value? Its respective value is 1, right? Means its output is 1. As this value is less than or equal to 3, it should be 1, right? Means what they are trying to say now. So here, for example, I am assuming that 3 inputs are A, B, C, and I am assuming that this is a kind of function 1. The given requirement I am calling it as function 1. So I am trying to say it as function 1. Okay. So when we are going to have 3 variables as input, what are the different possibilities are there? 000, 001, 010, 011, 100, 101, 110, 111. Guys, for the sake of clarity, I split it into 2 parts. Okay, fine. Now observe. So what the statement 1 is requiring? When the given bits converted to the decimal value, it should be less than or equal to 3. Then I need to place the value as 1. Otherwise I have to place it as 0, right? Guys, observe. Is the decimal value of this binary value is 0 or not? Yes. If I write in red color or in green color, this value is actually binary value is 0. This value is 1, this value is 2, this value is 3, and 4, 5, 6 and 7, right? According to the question, here you have to place 1 as 0 is less than or equal to 3. Here also you have to place 1, here also you have to place 1, here also you have to place 1, right? Because the reason is it is less than or equal to 3. But coming to the decimal value 4, it is greater than or equal to 3. So I can say that I have to place its value as 0. This is what their first requirement. And try to read the second one. The second one is output is 1 when the binary value of the input is even number. Even number means assume that I am calling it as F2. Means when I have to place the 1 when you said that the decimal value of this binary number is even number, right? So guys, you know 0 is an even number. Yes. 2 is an even number. Yes. And 4 is an even number. 6 is an even number. And for all the odd numbers, we have to place them as zeros, right? So this is what their question. So according to their question, we have constructed truth table. Truth table means, guys, so basically when somebody asks you to construct a combinational circuit, basically you have to identify what are the given requirements or what are the various kind of specifications given. After analyzation, you have to construct the truth table for it. After constructing the truth table for it, you have to solve it, right? You have to solve it either through Boolean theorems or it through K-maps. Then finally, you are going to construct circuit. Guys, this circuit you can able to construct either with help of basic gates, this is one of the procedure, or you can able to construct it through multiplexer, or you can able to construct it through demultiplexer, or you can able to construct it through decoder, right? Yes. Okay, fine. So here we analyzed first requirements or specifications by understanding the way I have explained, and second one is truth table we have constructed. Next, we need to solve these respective expressions, right? We need to solve the respective expression, right? For example, how we are going to solve the function 1? We can able to solve it through basically through normal procedure, right? Boolean theorems we can able to solve, right? How we are going to get f1 means by taking all minterms, So minterms are like a bar, b bar, c bar plus a bar, b bar, c plus a bar, b, c bar plus a bar, b, c. Okay, guys. So here, so trying to solve this kind of Boolean equation is going to be a difficult task when we are going to apply with the Boolean theorems, right? So the problem is it may take time. It will take time, and it may produce an error prone also, right? That's the reason we are moving for K-maps. So in K-maps, I have to construct a 3 variable map, right? Because we are having here 3 variables, right? So the variables are like A, B and C. So 0 is an input and 1 is an output at the A side. As you are having 2 variables at the x-axis, we need to have 0, 0, 0, 1, 1, 1, 1, 0. And for what values they placed 1 here? For 000, for 001, 010, 011, they have placed 1s, and for the remaining value they placed as zeros. Now, what is the maximum subcube is possible in order to solve this one? Right? So you can able to solve with the help of this 4. Right? So if you are able to solve it, you are going to get the expression as a bar. So the function f1, they are simply defining it as a bar. If you want, you can understood, guys, by simply taking here. If you are able to observe, whatever the input A is there, that input complement you are producing as output. Whatever input A is having 1s, the complement is zeros. That's why I am simply saying that f1 I can return in terms of A complement. Similarly, you can try to find out for f2, guys, right? So f2 means you are going to take out all the minterms of 1s. So all the minterms of 1s are A bar, B bar, C bar, or A bar, B, C bar, or A, B bar, C bar, or A, B, C bar, right? So this is what the last one, A, B, C bar. So trying to solve it is a kind of again a maybe error prone. So that's why I am going to take here also a K-map. A, B, C. So 0, 0, 0, 1, 1, 1, 1, 0, 0, 1. So whenever I am going to place the values, so whenever it is 000, I am going to place the value. Whenever 0, 1, 0, 0, 1, 0, I am going to place the value, and 1, 0, 0, I am going to place the value, and 1, 1, 0, I am going to place the value. Now, what is the maximum subcube possible here, right? What are the prime implicants are possible? Prime implicants are many, right? This is a prime implicant, this is a prime implicant, and this is one more prime implicant. But what about the essential prime implicant? I can make simply use this combination, the red color, right? If you are able to solve the red color combination, you are going to get AB removed, A removed, and on the x-axis, B is also changes from 0 to 1. So B is also removed. Only C is not changing. So there is C bar. Guys, if you are able to observe here, means F2 is simply a C bar. A C bar, right? If you are able to observe here, whatever the input that is there at the C level, it's going to get its complement. 0 means it is 1, 1 means 0, 0 means 1, 1 means 0. Like that here also. So F2 is simply a C complement, right? Now, can you able to construct the circuit diagram for this? Yes. Let us observe. So I am going to have three inputs, A, B and C are the three inputs are there. I am trying to construct with basic gates. Okay, fine. So if you want to get F1, so the function F1 is A complement and F2 is C complement, right? So guys, so here how we are going to get the F1? By simply making use of NOT gate. So then whatever output that I am going to get, that I can call it as F1, right? And how we are going to get the F2? Simply the complement of this one. That's it. So this is simply basic gates circuit design, right? With the help of simple basic gates we have constructed, right? This is the one way of solving the given question. But can we able to do it with help of MUX? Yes, right? Guys, if I are able to try to construct with the help of MUX, see guys, basically MUX means it's a kind of 2 power n inputs and it's going to produce one output based on n select lines. Guys, if you are able to observe here, observe how many inputs are there? 3 inputs are there, right? So 3 inputs are there, but how many possibilities are there for all these 3 inputs? Like 8 possibilities are there. So I can design it in such a way that, so here the possibilities are 8, so I can take it as 8 by 1 MUX. So for the easy construction, right? 8 by 1 MUX I have constructed, right? So in 8 by 1 MUX we are going to have pins are ranging from 0 to 7, right? 0, 1, 2, 3, 4, 5, 6 and 7. If I say technically, basically I can call it as I0, I1, I2, I3, I4, I5, I6 and I7. And you are going to produce the output. Assume that my output producing is F1, and this F1 you are going to get because of 3 select lines, right? So you know, right, it's going to have n select. If we say that this is 2 power n means 2 cube by 1, where n is 3. So I can say that S2, S1 and S0, right? Now observe, if you are going to pass the respective data, it is going to produce respectively, right? For example, if I pass the data as 100, it is going to produce the respective value as 0. Simply I can say whatever the input that you are going to be produced, like for example, if I say it as 0, 1, 1, meaning that, so the second line is going to be connected to the output, right? Second line means what? That will be the output 1. If you are going to give the input 1, 0, 1, so fifth line is going to be connected, then that is going to produce as output. So for the red color you are going to get 0. So this way you are going to get the function F1 is going to be built. Similarly, if you would like to implement function F2, can I able to implement with the help of the same MUX? No, it is not possible. So we have to take one more MUX, where this MUX is of size 8 by 1 MUX, which is going to take again the inputs are from I0 to I7, and the select lines are S2, S1 and S0, and this is going to be defined for F2. So it is same as like the MUX concept, right? So what are the input that I am going to get? For example, here my input is 1, 0, 1. Again, fifth line is going to be traversed to here, which it is going to produce a value as 0. Similarly, if I am going to give 100 as input, fourth line is going to be produced as output, and it is going to produce a value 1. This is the way MUX can be implemented. Similarly, can we able to implement with the help of decoder? Yes, we can do, right? So if you are going to do with help of a decoder, for example, decoder. So what kind of decoder we can able to use? you can able to simply use 3 by 8 decoder. Yes, if it is 3 by 8 decoder, we can able to have only single 3 by 8 decoder, right? Whereas coming to, if you try to implement with the help of MUX, you required uh, 2 MUX of size 8 by 1. But coming to 3 by 8 decoder, it is enough for us to take only single 3 by 8 decoder. So I can call it as S2, S1 and S0, and outputs are O0, O1, O2, O3, O4, O5, O6 and O7. Okay, fine. Now how it will work? If I am going to pass the input as, observe anything, 011, right? Before passing the input, try to construct the circuit for F1. What is F1? F1 is simply defining as 0, 1, 2, 3, 4. Simply defining as 0, 1, 2, 3, 4, right? Meaning that you can able to construct the circuit like this. Either 0 or 1 or 2 or 3, you are going to have an OR gate. Simply you are going to get F1. Similarly, how we are going to get F2? F2 we are going to get because of either 0 or 2 or 4 or 6. All are even numbers, right? So I can write with different color. 0, 2, 4 or 6. This is for F2. Guys, observe. Now with the help of decoder, I can able to construct with the help of single circuit, right? So I can call it as 3 by 8 decoder. Okay. Now try to analyze. If I am going to pass the input 011, 011, what might be the output you are going to produce at F1? F1, you are going to produce the output as 1, because 011 means signal is passed to O3, and this is connected to this one. So in OR gate, when one input is high and irrespective of other remaining inputs, it is going to produce the high voltage. High voltage means 1. Guys, this is only we got, right? For 011, for function is defining 1. Similarly, for example, if we take 101, let me take it with other color. Any other color, right? 101. If 101 is there, fifth line is going to be activated, right? When fifth line is going to be activated, is power is transferred to any one of the circuits? No. When power is not transferred to any one of the circuits, then you are going to get here as 0, here also 0. That means that your output is 0, right? Your output is 0. Similarly, try to pass the 101. 101. When 101 is passed, observe the thing is here. When 101 is passed, you need to get the value as 0 for F2 also, right? That's why you got 0. Now try to pass 100. 100. When you pass 100, you are going to get fourth line is going to be activated. Then my power is going to be transferred to this particular function. So here you are going to get 1, and is it connected to this one? No. Here you are going to get 0. Like this, single decoder can be used for to construct multiple functions. That is the advantage of decoders, right? Yes. So guys, can we able to construct with the help of 4 by 1 MUX? Yes. Can we able to construct with the help of 2 by 4 decoder? Yes, we can able to construct, right? So for time being, I will try to construct with the help of only MUX mode, right? So instead of taking with the help of 8 by 1 MUX, can I take with the help of 4 by 1 MUX? Means I am trying to write the something in terms of some representation, right? So guys, what you can do? So F1, can I write it as? Can write it as when you are going to have 00 as input, 00 input, and F1 you are going to get it as 11. You are going to get it as 11. Meaning that instead of seeing the input C, I am going to get the value 1. Similarly, when you are going to have 01, irrespective of C, I am going to get the value 1. See, if you want to get the clarity, you can go with the previous video. 1, right? Similarly, if you are going to give 1 0 as input, irrespective of C, it is going to put the value 0. When you are going to have 1 1 as input, irrespective of C, it is going to get the value 0. Right? Means here I can write in short terminology for AB, if you are going to have 0 0 0 1 1 0 1 1, the function f1 I can write without the help of other variable C. So the values here you got are 1 1 0 0 1 1 0 0. Similarly, can I write the function for f2? Yes, right. So f2 is what? So if I am going to give the value 0 0 0 0, you are going to get 1 0 as output, right? 1 0 as output means which is simply complement of C. Yes, so I can write as C complement. Similarly, when you are going to give 0 1 as input, you are going to get 1 0 as output. 1 0 as output means it is also kind of C complement. Similarly, 1 0 as input, again it is a complement of C. 1 1 as input, again it is also a complement of C. So I can write the F2 in terms of the another way as C complement. So this will be the C complement, C complement, C complement and C complement. Right guys, now can you construct the circuit for this? Yes. So if you are going to have 4/1 MUX, means you are going to have 4 inputs. Assume that I0, I1, I2 and I3, and select lines are S1 and S0, and this is for function 1. See, for every function you have to write the separate function, and I am going to take one more MUX and I am connecting to the same select lines in order to reduce the usage of the wires. I am going to have 4/1 MUX. It is going to produce the output F2, right? And you are going to have the inputs I0, I1, I2 and I3, right? Guys, you know, right? Now to get the output F1, you have to pass the 0 0 as 1, 0 1 as 1 and 1 0 as 0, 1 1 as 0. Now it means that can I make it as I0, I1, I2 and I3? Yes. So meaning that I0 value is 1, I1 value is 1, I2 value is 0, I0 value, I3 value is 0, then your circuit F1 is going to be worked as per the given requirement. Meaning that if it is less than or equal to 3, it is going to produce the 1, otherwise it is going to produce 0. Similarly, for F2, what might be the inputs? The inputs are C bar. Okay, that's it. So this is the corresponding circuit diagram for the given requirement with the help of 4/1 MUX. If you want, you can just cross check with 1 or 2 examples. For example, I am trying to check it with 0 1 1. When it is 0 1 1, so A is A, B or 0 1, meaning that the second line is going to be activated. This line is going to be activated and it is going to produce output, right? Meaning that here you got one output. Yes. So for 0 1 1, you got the one output. So it is working perfectly, right? Here also you will pass the same thing, right? If you are going to pass 0 1, this line is going to be activated and it is going to pass the power, right? But what might be the value? You are going to get C bar. What is C bar here? C is 1, C bar is 0. So it is working, right? For F2 it is 0. 0 1 for F2 it is 0. So like this it will work perfectly, right? So you can just simply understood the procedure how we are going to do. Like you have to go with the requirements understanding, truth table, K maps, then circuit design, then you will get the perfect answer. I hope you understood clearly. Thank you.